Hello everyone, I am Dr. Rajesh and I am again with you with second video lecture on fluid mechanics. In the earlier video lecture we have studied the definition of fluid mechanics and we have studied that fluid mechanics is the mechanics of fluid. And what about fluid? Fluid is something that has tendency to flow. Then we studied that where this branch fluid mechanics is used. So this branch fluid mechanics is used in mechanical engineering, chemical engineering, geophysics, biology, etc. Then we studied the types of fluid based upon the incompressibility of fluids. Compressible fluids are those fluids, as the name indicates, that could compress, means whose volume could change upon the application of shear stress. Best example are gases, we have studied it last time. And incompressible, those are incompressible, means there is no change in the volume upon application of shear stress. And the example are liquid and plasmas. So this is the example of incompressible fluid, and this is the classification of fluids based upon the compressibility and incompressibility of the fluid. It is given by two types: compressible fluid, incompressible fluids. Okay, fine. So that up to here we have studied in the last lecture. Now we will move further and will study here liquid fluids are further divided into two categories. Liquid fluid, those are categorized as incompressible fluids, are further categorized into two types: ideal fluids, real fluids. Ideal fluids are those fluids that are non-viscous fluids, and real fluids are those fluids that are viscous fluid. Non-viscous means that doesn't have viscosity, and viscous fluid means that has viscosity. So now we have the classification of liquid fluids into two types. One is ideal fluids and real fluids. Sometime in the examination this question could be asked, that what is ideal fluid and what is a real fluid. So you have to simply mention them. One is non-viscous, ideal one is non-viscous, other is viscous one, real one. Like it's real, the things that exist in the reality, this word has been derived from there. So the things that exist in the reality or the fluids that exist in the reality are real fluids. Real fluids do experience the viscosity, so they have the viscosity, so that is why that they are called real fluid. And the thing that the fluids that don't have any viscosity are called ideal fluid. That idealism, that no viscosity at all, something like that. So ideal fluids are those fluids that have no viscosity. Okay, so what is the viscosity? It is the resistance. Roughly speaking, viscosity is the resistance offered to the flow of the fluid. So viscosity of a fluid is the measure of its resistance to gradual deformation by shear stress or tensile stress. For liquid, it corresponds to informal concept of thickness. For example, honey has a much higher viscosity than water. For liquid, thicker the liquid, higher it will be viscous. Like in case of honey and water, two you have to take. Honey has higher viscosity than water. So because, and by seeing its physical appearance, you could see that honey is thicker. So being thicker, it has the viscosity. So that is also, it is also being mentioned that it corresponds to informal concept of thickness. Informally, by having idea of the thickness, we could judge the which one will be having the higher viscosity? Water has lesser viscosity than honey. So these two are familiar example from the real life. We all are familiar with honey and water. So that is the concept, that honey has a much higher viscosity than water. Now we will study a velocity at a point of a fluid. So we have to study what is the velocity at a point of fluid. Let OP is equal to R. This OP is equal to R be the position vector of any particle in fluid at time t. So at time t, this is the position vector of any particle in time t. So this is in time t. Okay, fine. So what is position vector? If it is asked that what is position vector, position vector is a vector that specify the position of the object with respect to the light. We have 3 dimension. So with respect to origin, if it says specify the position of the object with respect to origin, then we say that it is a position vector. It could also be written as R, where R is xi, yj plus z k cap. So position of an object with respect to origin is called position vector. Fine. While displacement vector is the relative position. Displacement vector is position of the particle with respect to other particle. Okay, fine. So like we have here, I am again displacement vector. This is position p, this is position p dash. So this position with respect to this particle is called a position vector. And say if mark it as a straight line, if this is r and this one is r plus delta r, then this pp dash is a displacement vector. Fine. So that is the displacement. Displacement means position of the particle with respect to other particle. Position is the position vector, means position of the particle with respect to origin, and in displacement, position of the particle with respect to the other particle. Okay, fine. Now move further. OP dash is a position vector of this particle p dash with respect to origin, and having coordinate r vector plus delta r vector be the position vector of the same fluid particle after time delta t, that is t is equal to t plus delta t. So now we will move further. Here we are now by triangle law in OPP dash will get, so PP dash plus OP is equal to OP dash. By using the triangle law we have this thing. So I am again plotting the figure over here. Say this is P, this is P dash, this thing is R, this thing is R plus delta R. This is in this direction, this is in this direction, and this is in this direction. Now apply the triangle law. This is O. Now apply the triangle law. Triangle law states that sum of this vector OP plus PP dash is equal to OP vector. So let me write OP plus PP dash vector is equal to OP dash vector. So this is the triangle law. Now put over here r plus delta r is the value of vector OP dash minus r to r will cancel out, so this r to r will cancel out, this will cancel out. Fine. So we are left with delta r only. So displacement vector pp dash is equal to delta r. So the velocity of the particle, we know that it is the change in the displacement with respect to time. Small change in the displacement with respect to small change, and delta t approaching to 0. Infinitesimal change with respect to time. So that will give the velocity of the particle at particular point, say p. So infinitesimal change. So this is dr by dt. Also velocity q vector obtained above depends upon the position vector and time t. So velocity at any particular point depend upon its distance from the origin and the time that have elapsed. So this velocity depend upon the time and the position vector. So if time t has elapsed, so it is and the position is here, so it will depend upon two factors. Here time is t plus delta t and the position vector is r plus delta r. So the velocity of a fluid particle depends upon the position vector and time. So velocity depends upon the position and time. So that is the expression for velocity that we have derived. Fine. Now in Cartesian coordinate system, if pxy is any point with respect to the frame of reference or rectangular Cartesian coordinate system oxyz, q is equal to coordinate xyz and time, we have studied that it is velocity is function of position vector and time. So if u, v, w are the Cartesian coordinate of velocity q, then q vector is equal to ui, x component of the velocity, y component of the velocity, z component of the velocity. Moreover, in vector form, velocity is written as dr by dt, where r is the position vector and it is xi cap plus yj cap and zk cap, where I cap, j cap, k cap are the unit vectors in the direction of x, y, z respectively. So from here, now we'll put this value over here and we'll get this is equal to this one, this is equal to this one, differentiating with respect to time the position vector, because, and then comparing, like we were given the position vector xi plus yj plus zk cap, dr by dt we have studied is nothing but dx by dt, differentiating each component. Okay, fine. Differentiating each component k cap is equal to this is q vector, and q vector you know is ui vj plus w k cap. Now comparing the coefficients of unit vector on both sides, we will get u over here is equal to this one, v over here is equal to this one, w over here is equal to this one. So fine. So this is the expression for the velocity in Cartesian form. Okay, fine. So that is the expression of velocity in Cartesian form. Now further we will study the fluid motion, and generally there are two description of fluid motion. First one is Lagrangian approach and another one is Euclidean approach. So these both approaches, Lagrangian approach and Euclidean approach, both approaches are very important and they form the fundamental of the all four units of this fluid mechanics. So these two approaches will be very important. I will be covering it in my next 1 or 2 lectures. So in this lecture I will not take much about Lagrangian approach and Euclidean approach, but I have introduced you the topic that in the next lecture I am going to cover up, that Lagrangian approach and Eulian approach. So these approaches are almost very important from every section of this fluid mechanics, and they will also be used in the fluid mechanics for the next semester. So you must take note of these two approaches, that what is the difference between them and how will you identify that which approach is being used in which question. So that is much more important than anything else, that we are able to grasp the idea, we are able to identify that which approach is being used in the question or in the fluid motion. So that is very important, and I can promise you that I will make you able to discriminate between the two approaches and clearly identify that which approach is being used in the given question. So I would expect you not to miss my next lecture. In the next lecture I will be describing these two approaches, that is Lagrangian approach, Eulian approach. So please stay connected and keep in touch and keep learning, stay healthy. So this is all I have from this lecture, and very soon I will be with you with my next video lecture. Till then, take care, bye bye, see you and meet you soon. Thank you very much.